Hello my dear students, welcome to computer science class. Let us continue with our chapter input, output and memory devices. In our previous video class we have seen the different types of impact and as well as non-impact printers. And then we have discussed about the plotters as well as the speakers. In today's video class, let us discuss about the computer memory devices. Memory is the most essential and the storage part of your computer system. We need memory in order to store the data, programs, instructions, information, wherein the storage will enable us to store the data so that we can use it for the later purpose. Computer memory is actually mainly divided in terms of the two units, that is the main memory as well as the secondary main memory. The main memory can also be referred to as the primary memory, where the primary memory is divided again in terms of random access memory and the read-only memory. The other type is the secondary memory, magnetic tapes, hard disk, floppy disk, optical disk, etc. So these are the two mainly how the computer has been classifying its memory. But there are different types of memory that exist in the computer system. The first is internal processor memory, that is where the a kind of a memory that has been stored in the processor itself. Even the cache memory is also an internal memory that has been closed in the processor itself. So we are having internal processor memory and the cache memory. We have primary memory and secondary memory. But mainly the computer system will divide the memory into only that is two forms. One is the primary memory, the other one is the secondary memory. Now, what are the different units that we are using in order to measure the secondary memory as well as the primary memory, that is in terms of bits and bytes. So bits actually is nothing but where the data is in terms of binary digits, that is in terms of zeros and ones. And what is this byte? That is 8 bits make 1 byte, isn't it? So let us see the different units, the units that are being used to measure the computer memory. You can see here 1 bit is equal to, these are nothing but the binary digits in the form of zeros and ones. 8 bits make 1 byte. Similarly, 1024 bytes make 1 kilobyte. That is 1024 bytes in the sense that is 2 raised to 10 bytes is equal to 1024 bytes. That makes 1 kilobyte. Similarly, 2 raised to 20 bytes, that is 1024 kilobytes makes 1 megabyte. Similarly, this is what 2 raised to 30. Okay, similar 2 raised to 40, 50, 60, 70, 80, 90 and 100. Okay, so 1024 megabytes makes 1 gigabyte. So 1024 gigabytes makes 1 terabyte. 1024 terabytes makes 1 petabyte. Okay, 1024 petabyte makes 1 exabyte. So 1024 petabytes in the rate what 2 raised to 60 bytes. 2 raised to 60 is equal to 1024 petabytes, that makes 1 exabyte. 1024 exabyte, 1 zettabyte. 1024 zettabyte makes 1 yottabyte. 1024 yottabyte makes 1 brontobyte. Alright, 1024 brontobyte makes 1 geop. So geop byte is the highest memory unit that is used to measure the computer memory. I hope you are able to understand. As I said, the computer has been classified its memory in terms of two types. One is primary memory and the secondary memory. Here actually the memory units are the storage areas in our computer system. So herein we are using two different terminologies. One is memory and the other one is storage. So when we need to usually refer as a memory, the term memory is usually refers to the main memory or the primary memory of a computer system. Whereas the storage is used where the memory is exist onto the CDs, floppy disk, hard drives, okay, like onto the secondary storage devices. The memory that exists on secondary storage devices, that time we use the terminology as storage. Whereas if the if the memory is being stored in terms of chips, that is in terms of ICs, integrated circuit, okay, wherein the primary memory will store its data in terms of usually in terms of chips. Here you can see these are all the chips. So such kinds of memory we usually refer it as an physical memory which are capable of holding the data as well as the instructions. Now let us discuss the different types of primary memory, that is about the RAM and ROM. So RAM stands for random access memory and ROM stands for read-only memory. First we shall discuss about the read-only memory. So in case of read-only memory, the information is being pre-recorded or the information is burnt at the time of manufacturing itself. Okay, see, the process of programming into this ROM chips, we call it as burning. Okay, the process of writing the contents, moving the contents or writing the contents into this memory chip, we can refer it as, burning. So the information is being pre-recorded or burnt into this ROM chip at the time of manufacturing. See, once the data has been written into this particular ROM chip, the contents cannot be erased, but we can read the contents several number of times. Okay, since it has been burnt at the time of manufacturing itself, we usually are able to read the contents out of it many a times. If we want to make any changes or the modification, it is not possible. Alright, see, this ROM is a kind of non-volatile memory. What is non-volatile? Non-volatile in the sense, once the computer is switched off, okay, the contents of ROMs are not erased, but the contents will be stored permanently. Such type of a memory where even when the power supply is not provided, but still the contents remains as it is. Such type of memory we usually refer it as what? Non-volatile memory. I hope you are able to understand. Then what kind of information is being stored into these ROM chips? ROM usually stores the critical programs such as the program that boots the computer system. Booting in the sense, suppose when you on your power supply, okay, your computer system starts, the process will be on. So that, we call it as, booting the computer system. So usually this ROM chip consists of the instructions like for the bootstrapping, that means the self-starting process where the computer actually loads all the basic softwares are being loaded into the computer memory once after the power supply is on. That process we usually call it as booting the computer system. So such kinds of critical programs have been stored into the read-only memory. I hope you are able to understand. Now we shall see the different types of ROM. So the first one here is PROM. PROM stands for programmable read-only memory. Second one is EPROM, that is erasable programmable read-only memory. The next one is EEPROM, that is electrically erasable programmable only read-only memory. So these are the ROM chips and here it is a RAM. You can see the difference. Now let us discuss one by one. So what is this PROM? PROM, here it is a kind of memory onto which the data could be written only once because the contents are being programmed by the manufacturer himself by using a special device known as PROM programmer or the PROM burner. Here you can see by using this particular special device called as PROM burner or the PROM programmer, okay, the contents are being burnt or pre-recorded into the PROM chip at the time of manufacturing. So this PROM chip is again a kind of non-volatile memory. Non-volatile means the contents remains as it is even when there is no any power supply. Alright, I hope you are able to understand. So here the contents are being written permanently and cannot be erased or modified. See, if the PROM is being programmed with any error or if the chip needs any updation, then that particular chip is being discarded and a new PROM chip will be created replacing the old chip. That is why the contents could be written only once and you can read the contents several number of times. Then what is the variation? This is a drawback. So what is another variation of this PROM is EPROM. So herein its EPROM actually stands for, that is erasable programmable read-only memory. Again this is also a kind of PROM chip only, but the contents could be erased and reprogrammed without being replaced. That is what is erasable programmable read-only memory. So herein the information could be erased and reprogrammed using again a special PROM programmer or the PROM burner itself. Here you can see the EPROM. But how this contents are being erased? Okay, here you can see at the middle there is a transparent quartz crystal window at this top of this particular EPROM chip, wherein the UV light rays are being passed in order to erase the contents of this EPROM chip. In this the quartz crystal window, okay, the violet light is being passed in order to erase the contents. So this EPROM differs from this PROM actually, where in case of PROM the contents are being written only once and cannot be erased, whereas in EPROM by using the ultraviolet light we can erase the contents and reprogram it. Now this EPROM is again a non-volatile in nature. That means the contents will not be erased even when there is no any power supply. The process of programming this EPROM we can refer it as burning. See, only several number of times the data could be erased. So therefore we have the next variation of this EPROM, that is electrically erasable programmable read-only memory, which has also been referred to as an EEPROM. I repeat, electrically erasable programmable read-only memory. So this is equivalent to EPROM only, but it does not require any kind of ultraviolet light in order to erase its content. In fact, it is erased by exposing to an electrical charge. Okay, by that you can erase the contents and you can reprogram it again. So it is again a kind of non-volatile in memory. This EEPROM is not that as fast as in case of random access memory, okay, or any other types of ROM. Okay, here example is the flash memory is a special type of EEPROM wherein the contents are being erased and reprogrammed. So here how the contents will be erased, that is at a time only 1 byte of a data could be erased. That means the erasing will be taken place by byte, okay, at any point of time, rather than entire contents will not be erased at once. So therefore it is quite slower when we are comparing to the other types of ROM as well as the random access memory. So this is all about the different types of ROM. A very important question, what is ROM, and explain the different types of ROM. Now let us discuss about the next memory, primary memory, that is random access memory. Alright, so what is this random access memory and what are its different types of random access memory? We shall discuss. This random access memory is also being referred to as an internal memory or the primary memory. You can even refer it as main memory that stores your data temporarily. So here let us see. Yes, so this is how you are able to find that is random access memory. So the data is being stored in terms of chips. Alright, so the CPU will fetch the program instructions from the random access during processing, and it stores the results of the calculations in the random access memory. As we know already this point, we have discussed this in the block diagram. As the user enters the input into the computer system, that input data will first reaches to the memory unit, that is in the random access memory. This memory unit will pass the data to the CPU, isn't it? So therein the data will be received by the control unit. Control unit will divide that entire data into the series of logical instruction, and each of the instruction will be passed to the ALU for the processing purpose. And then once the calculation has been done, or during calculations, the intermediate results could be stored into the random access memory, or the final results could be stored into the random access memory before that has been sent to the output unit. So there may be several number of times the data exchange may takes place between the main memory as well as the CPU, isn't it? We have studied this in block diagram. We have studied that one of the characteristics of C++, that is about the computer, that is automation. So therefore CPU, whenever it requires any information or the data during processing, it usually fetches the data from the random access memory, and it also stores the results of the calculations in the random access memory. So once the computer has been switched off, whatever the contents or the information is been holded by this RAM will be entirely erased. Therefore, the random access memory is a volatile form of memory. I hope you are able to understand. So whereas in case of ROM, it was a non-volatile memory wherein the contents were not erased even when there was no any power supply. But here, if the power supply is not being provided, then the RAM chip cannot hold its contents. So this is a volatile form of memory. Alright. So in RAM, every bit of memory space is having identified by a unique number called as an address. You can see here the memory unit is having the number of storage locations. So each one of the storage, each one of the cells or each of one of the storage has been identified by a unique address called as the cell address or the memory location, you can refer it. So with these addresses, okay, it helps in storing the data into the memory as well as retrieving the data from the memory. Suppose whenever an input data, suppose an user enters an input data, that input data will be stored in this computer memory in the form of storage location, in the form of storage cells. The data will be stored at some specific location. That means this location will help you to store the data. And suppose whenever you want to print your output onto the display screen, that means you need to know the location, then you are able to print the data. So it will even help you to retrieve the contents out of this memory. So then what kind of operations that we can perform onto this memory unit is, we can perform the read and write. So what is this read? Read is nothing but it transfers the information from the memory to the other devices. What is write operation? It transfers the information from the other devices to the memory. Say for an example, for the write operation, whenever the user enters the input data through the input device, that data comes and it will be stored into the computer memory. Isn't it? We are transferring the information from the other devices to the memory. Other in the sense, we are transferring the information from the input device to the memory. That operation we call it as write operation. Then what is read operation? See, whenever we transfer the information from memory to the other devices, when we want to display the output, okay, the data after once the calculation is performed by the CPU, the final output will be stored into the memory before it has been sent to the output unit. So if I want to show the output or display the output, then the data has to move from this memory unit to the output unit. So if we are transferring the information from memory to the other devices, that operation we actually call it was read operation. So therefore, what kind of operations we can perform onto the this random access memory is read and write. I hope you are able to understand. See, a memory that performs both the reads and write, we always refer it as a random access memory. So how this communication is happening from the input to the memory, memory to the output, memory to the CPU, by using the FSB, that is front side bus. See here, whenever the CPU wants any any information or the instructions for the calculation purpose, CPU will request the data to the random access memory. So once the request is been received by this random access memory, whatever it is, the instruction is been asked by the CPU will be provided to the CPU by using a bus called as FSB, that is front side bus. Bus in the sense they are the serial lines actually. It's a data channel. Okay, this FSB, it is a two-way data channel that sends the information from the CPU throughout the entire motherboard to the various components. It will send the data through this bus. We can send the data to the RAM, we can send the data to the hard disk, we can send the data to the PCI slots. PCI slot is peripheral component interconnect that would help you to connect the video card, network card, sound card and TV tuner. So these things you need not worry, just understand this. What is this bus? So this bus is responsible, okay, for in order to transfer the instructions or the programs that has been required by the other components onto your motherboard. Similarly, when there is an exchange of information between the RAM and the CPU, this FSB bus is acting as two-way data channel. Two-way data channel in the sense it can send as well as receive the data from and to from the CPU as well as the random access memory. I hope you are able to understand. And this random access memory, it is volatile in nature, wherein it cannot store the contents. That means the contents will be erased when there is no any power supply. Now let us discuss the different types of random access memory. The first type is the static memory, that is static random access memory. It's a kind of semiconductor memory that uses a bistable latching circuitry in order to store the each bit. Usually the memory cell will be made up of the capacitor as well as the transistor, each memory cell. Alright, so herein this static random access memory, it is made up of the bilatching circuitry along with the transistors. So this static random access memory is quite faster comparatively to the dynamic random access memory. Alright, so it is bilatching circuitry in the sense it is a flip-flop we can call it, or it is a latching circuit that uses two stable state in the form of zeros and ones that would help you to store the information into it. Alright, we have the another form of random access memory, that is dynamic random access memory, that has to be periodically refreshed. So herein the data will be lost when the memory is not powered. So herein what happened in case of dynamic random access memory, it is made up of both the capacitors and the transistor. These capacitors is the one which is responsible to hold the data. These capacitors requires constant memory, constant power supply it will has to require. Alright, so therefore this dynamic random access memory needs to be refreshed constantly when you are comparing with the static random access memory. Both are again in case of they are volatile in the nature. Until the power supply is supplied, it will hold the contents. Once the power supply is it is stopped, it cannot hold the contents. Static random access memory, it is made up of only the transistor and bilatching circuitry. So it may not that much requires, the refreshing is not required, but power supply is needed. But in case of dynamic random access memory, since it is making use of capacitors as well as transistor, a constant power supply is needed and a constant refreshing is being needed. So by itself, the computer itself, it will refresh its the dynamic random access memory will by itself it will get refreshed. So as and when it will refresh, it will retain the contents what it has been holding. Alright, so these are the two different types of the random access memory, that is static random access memory and the dynamic random access memory, and both are in volatile in the nature. The other forms of we are having this random access memory is what, that is SDRAM, synchronous dynamic random access memory, and the double data rate random access memory. So this SDRAM stands for synchronous. So herein what happened, the SDRAM is actually the memory speed is being linked or associated with the clock signal onto our motherboard. So memory speeds are being associated with the clock signals onto the motherboard. So this SDRAM is being completely synchronized with the clock signal. Therefore, its name is being referred as synchronous dynamic random access memory. The other one is what, double data rate random access memory. Even this is also actually been synced with the clock signal. The SDRAM, okay, the memory chip will work only at the rising edges of the clock signals. You can see here it is a non-DDR. Non-DDR in the sense it is a synchronous dynamic random access memory. Clock signals, I said, see, whenever the clock signal is high, it is transferring the data. Whenever to the CPU, whenever the clock signal is low, it is not transferring. Again, whenever the clock signal is high, there is a transfer of data. Low, there is no transfer of data. That means this synchronous dynamic random access memory will provide that there will be an exchange of data between the random access memory and the CPU. We know that through the front side bus. So this synchronous dynamic random access memory will transfer the data only at the rising edge of the clock signals. Alright. Then what is this DDR, double data rate random access memory? It is able to transfer the data to the CPU both at the rising edge as well as the falling edge of the clock signal. This is high 1, this indicates 0, this is 1, this is 0, this is 1, this is 0. At the both the times it is transferring the data. Therefore double data rate random access memory is much more faster than the synchronous dynamic random access memory. I hope you are able to understand. So these are all the different types of random access memory: static random access memory, dynamic random access memory. Again we are having SD random access memory, that stands for synchronous dynamic random access. Herein these both are being associated, synchronized with clock signals, means they are working which is associated with the clock signal. Alright, so therefore we are referring here the word terminology as synchronous dynamic random access memory. All these are volatile in nature. We have another type of random access memory is EDO, that is extended data output. This extended data output is again a kind of random access memory that will help you to improve the time to read the information from the memory onto the faster microprocessor such as Intel Pentium. See, the more the data transfer is rate between your random access memory and the processor, the more the faster your processor will execute the instruction. The more the faster your CPU will execute the instruction, the more the performance of your computer system will increase. So EDO is a kind of random access memory that is used to exchange the information between the random access memory, that is a memory chip, as well as between the faster microprocessors. Such as an example, we are having Intel Pentium. So this EDO was initially optimized, that means it was being developed, it was being used for the processor which we were using, or of around 66 megahertz Pentium we were using. Okay, Intel Pentium, for this processor actually the EDO was being designed. So these are the different kinds of random access memory we are having. So in today's video class we have discussed what is a memory, what is a storage, what are the different units measurements we are using to measure the computer memory, right? We have seen what is ROM, what is RAM, what are the different types of read-only memory, and what are the different types of random access memory. The next concepts we shall discuss in our next video class. Thank you, students.